Hello everyone, this is the continuation of the video just above this one. So this one too is about probability. So here we have a question. It reads 13 cubes of the same size numbered 1 to 13 are placed in a bag. If 2 cubes are drawn at random from the bag, one after the other and not replaced, what is the probability that question 1 both cubes are odd numbered? Question 2 only one is even numbered. So we have to be very careful with this question. We should understand what it means when they say an odd number and what it means when they say an even number. So just to remind us, an odd number is any number which when divided in twos leaves one not matched in twos. Or in short, an odd number is a number which when divided by 2 gives you the remainder 1. Then an even number is a number which when divided by 2 gives you the remainder 0. So that is the difference between the two numbers. So in this question, the numbers are running from 1 and they are ending on 13. So we should identify which ones are odd and which ones are even. So when you start from 1, you skip the number just like that. Those numbers are going to be called odd numbers. So these numbers will be 1, 3, 5, 7, 9, 11 and 13. So those will be the odd numbers. Then 2, 4, 6, 8, 10, 12 will be even numbers. Then from there, we shall use the ideas of probability. We know that probability is counted or calculated out of 1. So we are going to rely on the key body or key bullet of probability, which is a tree diagram. So this is an ECZ question. So mostly we rely on the tree diagram. Okay, here we go. Let's solve the first question, which says both cubes are odd numbered. But the first thing that we are going to do, we are going to use a tree diagram. So this is how I'm going to use my tree diagram. So just a minute. Okay, I've been told that I've got odd numbers. So the numbers first, they are running from 1 to 13. In simple terms, 1, 2, 3, 4, 5, so these are the numbers which we have. These are 1, 2, 3 onwards up to 13. So these are the numbers. Okay, so from these numbers, the odd numbers, we have odd numbers. So the odd numbers are 1, 3, 5, 7, 9, 11 and 13. So these are the odd numbers. Then the even numbers, are 2, 4, 6, 8, 10 and 12. Then from there, let me just say odd numbers. How many do we have? So we just use initials. Odd numbers, how many do we have? So for odd numbers, we have got 1, 2, 3, 4, 5, 6, 7. So I've got 7 odd numbers. Then for even numbers, how many do we have? We have 1, 2, 3, 4, 5, 6. So even numbers are 6, odd numbers are 7. So together we are having a total of 13 numbers. So keep this in mind. This is what we have. Okay, so going to our question, which is saying calculate the probability that both cubes are odd. So I said we start with a tree diagram. So our tree diagram is talking about odd numbers and even numbers. So this is what our tree diagram is talking about. So for odd numbers, we are saying we have got 7 of them out of a total of 13 numbers. Then for even numbers, we are saying we have got 6 numbers out of a total of 13. So this is what we have. So now, looking at what I said in the previous video, if you add the numbers on the branch, it should give you 1 always. It should always give you 1. So this is the first selection. If the numbers are selected for the first time, this is what we expect. So suppose they are selected again. We have been told that the numbers were selected 2 times, one after the other. So if they select again, suppose they select odd. So the numbers for odd will reduce to 6 and the total will reduce to 12 since there is no replacement. The probability of this guy is still 6 because it is not the one which was selected at first. So it maintains, but the total changes to 12. We come to this side. Make sure you maintain. If you said odd, even here it will be odd and even. Even was selected, meaning the odd still maintains to have 7, but the total should change to 12 because there is no replacement. If we go for even and even, since the even was selected at first, it has reduced to 5 as well as the total has reduced. So this is how it should look like after the calculations. Then we have the final results. This is a path of odd, 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 odd. Then this is a path of odd, even, odd, even. So odd, even numbers. Then this is a path of even, odd. So this is a path of even, odd. And then this is a path of even, even. So this is even, even. So that's what we have. So take a look. This is how it should look like after you have done some calculations. Okay, so the first question is telling us that we calculate the probability that both cubes are odd. So we go on our tree diagram and check where there is OO from the final results. Where are we having OO? It's only here. Then we'll say, number 1, so probability that both are odd. So probability that both are odd, we only have one probability, which is here. Then make sure this is O and O. What was the first O? It was 7 over 13. The first O was 7 over 13. Then the next O was 6 over 12. So times 6 over 12. So remember, we said when you go to another branch, we put plus, but in this case, there is no other branch. So we're just going to consider this. Pardon me, let me remove the brackets. There is no need. From there, you can simplify this. 6 into 6, it's 1. 6 into 12, it is 2. Giving you 7 times 1 over 13 times 2. And this is 7 times 1 is 7. 13 times 2, it is 26. So that is the probability that both picked numbers are odd. So that is how we have come up with a calculation. The next question